here to talk to you about like terms and how to combine them. First thing I want to give you is a definition on what like terms are. First off, the easy terms, constants. Constants are those little naked numbers with no variables attached to them. Constants are like terms. You just add them or subtract them as you see them. The other kind of like terms are a little bit more difficult to think about because they involve variables. First off, the variables on terms must be identical in order for them to be considered as like terms. Secondly, those variables have to have exponents that match exactly. If both of those parameters are not met, then the two terms that you're looking at are not like terms. How you combine like terms is if they're constants, you just add them or subtract them as you see them. If those terms involve variables, you take that number stuck on front of the variable, that numerical coefficient, and you add or subtract those. At this point in the game, when you're combining like terms, you don't change the look of the exponents. If you see an exponent in your like terms, that should be in your answer. You're not going to change the exponent. Okay? Here's three expressions that I want to use to demonstrate what like terms look like and what they don't look like. Here we got an expression 2x plus 3y plus 4. We can't make this expression any smaller on account of these two letters do not match. Therefore, this expression is as simplified as it can get. This expression over here looks like it might have some possibilities. We have a couple of x's on these terms. The reason that we can't make this expression any smaller is because we have an exponent of 2 here and there's an exponent of an invisible 1 here. Because these exponents do not match exactly, we can't combine these like terms. Therefore, this expression is as small as it can get, as simplified as it can be. This last one over here is a perfect example of like terms. We have two terms, they both have x's in them. The exponents on those x's, which happen to be invisible 1s in this case, match exactly. So you can combine some like terms here, and what you do is you add the numerical coefficients on the front of the variables. So remember that a numerical coefficient is a number stuck to a letter. So I'm going to take a 2 and a 3, add it for a 5. The x stays the same. This 4 over here is a lone constant. We cannot combine it with anything because it doesn't have an x attached to it. So as simple as we can make this expression is 5x plus 4. Now that you know what like terms are, let's combine some. This problem right here, we got 3 terms, 3x, 1x, and 5. While you're getting the hang of this, it's really important to make those invisible 1s visible. So do yourself a favor and mark in a 1. That gives us a very real 1 to add the 3 to, and we combine 3x and 1x for 4x. So this 3x and 1x are going to be combined into a 4x. This 5 is just going to come along for the ride. It's not a like term. So this 3x and 1x became this 4x. This is as simple as we can make this expression. This one's a little bit more interesting. There's a couple of x's up here, but they're not like terms, are they? The reason that they're not like terms, this x squared and this x right here, is on account of this little exponent of a 2. If this one is missing its little exponent of 2, that outs it as a like term. So all we can do is look at these things. The only like terms we have up here are the constants, the 12 and the 7. So we can make this math problem smaller by writing it as negative x squared plus x and combine the 12 and the 7 for a 19. As long as you've got a negative x squared, an x, and a 19, at this point it doesn't matter what order those terms come in, as long as the sign that is directly to the left of each of the terms sticks onto the terms. So again, this is as small as we can make this expression. There are 1, 2, 3, 4, 5, 6 terms on this expression. And we're going to make this thing as small as we can by combining the like terms that we can combine. So, looks to me like we have 3 different kinds of like terms. First off, we've got a couple of things with x squareds on them. Here, I'm going to make that a color. Here and here. The next kind of like term that draws my eye is the terms with the y's. We have 2 terms with y's, 3y and negative 1y. Do yourself a favor, make that 1 visible, just like this. The third kind of like term we have are the constants. We've got a 3 and a 5. So what we're going to do is, with the terms with variables, we're going to add the coefficients on the front. The things that are just constants, we're just going to add them up like regular numbers. So first off, we have our 2x, take away 4x squared is negative 2x squared. So our red terms became negative 2x squared. Then we got our blue terms with the y's. We got 3y and negative 1y. So 3 take away 1 is 2, so we're going to have a positive 2y. So that's what became of our blue terms. Lastly, we have our constants. The green 3 and the green 5, both are positive, so add them up for an 8. And there you have a little introductory lesson on how to combine like terms. My name's Nicole. I'm a math teacher. Thanks for watching.